Welcome to the course Object-Oriented Design and Programming. I am Dr. M. Sivakumar, and in this unit, we will build a strong foundation in programming concept using C++. This subject is extremely important because object-oriented programming is the backbone of modern software development. Almost all large software systems, such as banking applications, operating systems, mobile apps, and web platforms, are built using object-oriented principles. In this unit, we will begin with basic programming concepts and gradually move toward advanced object-oriented ideas such as classes, objects, abstraction, encapsulation, and UML diagrams. I strongly recommend that you focus on understanding the concepts rather than memorizing code. Clear conceptual understanding will help you in exams, lab sessions, interviews, and real-world software development. Object-oriented programming, commonly called OOPS, is a programming approach that models real-world entities using objects. In OOPS, we combine data and the functions that operate on that data into a single unit called an object. This is very similar to real life, where an object has both properties and actions. The four fundamental principles of object-oriented programming are encapsulation, abstraction, inheritance, and polymorphism. These principles help us write programs that are secure, reusable, and easy to maintain. Encapsulation protects data, abstraction simplifies complexity, inheritance promotes code reuse, and polymorphism allows flexibility. Popular programming languages that support OOPS include C++, Java, and Python. Among these, C++ is widely used for system software, game engines, and performance-critical applications. Programming is the process of designing, writing, testing, and maintaining computer programs. A computer does not think on its own. It simply follows instructions given by a programmer. These instructions are written in the form of programs using programming languages. Programming converts human logic and problem-solving steps into machine-executable instructions. For example, calculating student grades, performing banking transactions, or generating reports all require programming logic. A good programmer not only writes correct code, but also ensures that the code is efficient, readable, and easy to modify. As software systems grow larger, structured programming techniques such as OOPS become essential. A programming paradigm is a style or method of programming. It defines how programs are structured and how solutions are expressed. Procedural-oriented programming focuses on functions and step-by-step execution. Object-oriented programming focuses on objects and their interactions. Event-driven programming responds to user actions such as clicks or key presses. Logical programming is based on rules and logical statements. In modern software development, object-oriented programming is the most widely adopted paradigm because it closely models real-world systems. This course focuses mainly on OOPS using C++. In procedure-oriented programming, the program is divided into small functions. Data is usually global and shared among these functions, which can lead to security and maintenance issues. The primary focus in POP is on the algorithm rather than on data protection. Languages such as C and Pascal follow the procedural programming approach. While POP works well for small programs, it becomes difficult to manage large and complex software systems. Changes in one part of the program may affect many other parts, making debugging and maintenance difficult. Object-oriented programming overcomes the limitations of procedural programming. In OOP, the program is divided into objects. Each object contains both data and the methods that operate on that data. This approach supports data hiding, meaning internal details are protected from outside access. OOP promotes modularity, meaning programs are built using independent modules. This makes software easier to understand, test, modify, and extend. OOP is especially useful for large-scale applications such as enterprise software and operating systems. As software systems grow larger and more complex, traditional programming approaches become insufficient. Object-oriented programming helps manage complexity by organizing code into reusable components. Classes allow us to reuse code efficiently, reducing duplication. Encapsulation improves security by restricting direct access to data. Debugging becomes easier because each object can be tested independently. OOPS is essential for developing reliable, maintainable, and scalable software systems. Let us understand object-oriented programming using a real-world analogy. Consider a student as an object. The student has attributes such as name, roll number, and marks. The student also performs actions such as reading marks and calculating grades. In programming terms, attributes represent data members and actions represent methods. This close resemblance between objects in programming and real-world entities makes OOPS intuitive and powerful. Real-world modeling is one of the biggest strengths of object-oriented programming. Let us compare procedural programming and object-oriented programming. In procedural programming, data and functions are separate. In object-oriented programming, data and functions are bundled together. POP offers limited data security, whereas OOP provides strong data protection. OOP supports better code reuse, scalability, and maintainability. Due to these advantages, most modern software systems prefer object-oriented programming. Object-oriented programming is widely used across industries. Banking systems use OOPS for secure transaction processing. Operating systems use it for modular design. Game development relies on objects to represent characters and environments. Web applications and embedded systems also heavily use object-oriented concepts. Learning OOPS is essential for any aspiring software engineer.